Hello sir, my name is Rajadan Jaydeep Mani and today I am here presenting ISE activity 2 of foundry farming technology. So my component name is V6 engine blocks. It is an automatic application used in Toyota Fortuner like SUV cars. Use and purpose. There is some use and purpose of the engine blocks is found in a combination of internal engine acting the spring for moving parts. They can move the parts. It support cylindrical bores for piston. They have cylindrical bores of piston, water jackets for cooling, oil lubrication, and bearing for crankshaft and camshaft, mounting points, escalator light, alternator, and transmitter. Some key functions of without stand high pressure up to 100 bar and temperature 200 degrees Celsius for combustion. They have temperature is 200 and high pressure is 100 bars up to 100 bar. Ensure presence alignment to prevent vibration and failure. In V6 configuration, V shape for compact design and smooth operations. So material with composition. So these are the some materials: gray cast iron, ASTMS A48 class 35. Composition, what is the composition? The C tip 3.2 to 3.5, and silicon is also include 1.8 to 3.7, and some are the more composition, and there are some properties of their material. So high calibration, the thermal conductivity, vibrations, tensile strength. They have some their properties. They can justify that product. It's build a strong metal. Okay, so why gray cast iron? Why we are choosing gray cast iron? Graphite provides self lubrication. They have some kind of lubrication. They have itself, and they can machinability. Cost efficiency is 0.5 dollar per kg. They have low cost efficiency, and aluminum have versus aluminum have $2 for 3 kg. They are some cheaper. Used 70% atomic engine blocks durability. So most of the cars are use their composition, use this composition and use that gray cast iron. Manufacturing forming process. So manufacturing, you can see here, silicon clay plus water for module, and detail the steps. So these are the some steps. We can start here. Pattern making, mold preparation, getting system assembly, material material and porosing. So what are the material making? They create a wooden or aluminum pattern with shrinkage alloy 1 to 2% and angle 1 to 3 degree. For V6 include core prints for water jet. So they are create 1 to 3% of uh, draft angle, and allowance is 1 to 2%. Okay. Mold preparation, pack green sand moisture is 4 to 6. They have some moisture 4 to 6% around into cope, top drag and bottom drag. Flux include 10 to 15 sand blast, and getting system is assembler super trapped runner and minimum turbulence and riser fielding. So they have some minimum turbulence and riser is filling also. So methylene forging, the furnace have 350 degrees celsius for 1450 degrees celsius, and the filling time is 20 to 40 seconds. They have some filling time, and for that 300 kg to 400 kg box are prepared. Solidification cooling. So controlling cooling is 2 to 4 hours. They have some cooling methods you can use it, but they have some limits 2 to 4 hours. But shrinkage and cleaning, Variable models remove sand 90% and fresh getting inspiration and fishing x-ray defects machine bores 0.1 to 0.5. They have some annuals 550-degree for their champ. Quality checks, hydraulic test for nicks and dimension scan. Advantage, low cost for large flexibility for prototypes and unique search. So we are seeing some diagrams of here. We can see step by steps their models and their steps. We can see first is pattern making. We are making the pattern that fulfill the shapes and fulfill requirement of the all of their objects. And mold preparation is most important because we can such have some mold they can use in the uh, automobile engines, so they have some stronger ability to sustain the course. So core instruction and mold soling and pouring is some techniques I will show you. So we can see a example and a diagram of the process, and we can see last year a diagram of the V6 block engine. We can sufficient to see that. So defects in components. So some cases have some defects, some cases have not defects, some have some property, but we can see some defects. uh, Defects cause location and effect of component. So we can see some proportion blowholes, trapped gas from so we can see trapped gas from most sand causes. uh, Air location is near surface or core, and effect on component is reduced strength. So also have shrinkage cavity. Volume is 3 to 7% of iron without feeding. So their cause is volume construction 3 to 7% in iron. It means it can occur in iron. uh, Thin section and internal voids leakage, some cold shut and low pouring temperature. We can such as we took that product and sitting down to for low temperature, they can located in thin walls. So it have also the thin wall for water jackets and some of the most defects and during manufacturing. So virtual examples, so we can see here some virtual examples of defects. You can see that A, B, C, D. So remedy to control defects. So some of the remedies to control defects, gas pouring. We can remedy is use dry core. So we can use dry core so they can gas not trapped in that property. And shrinkage cavity property riser design, they can have property riser design and implementation. What is the first gas property have implementation of 80% and direction of solidification. So 1.2 minus 1.3 into shrinkage, they have some formulas. So cold have increased the pore temperature, so we can increase the cold forming temperature. Low simultaneous software like shutdown. Sand inflation, hot they have some other cause and their remediation. So we can see here next. So for forming techno forming process calculations, so they have some calculation of giving data and density. So we can see here material have a given data, cavity needs shrinkage, riser, gating cavity, casting surface, pouring head, and G. So first of all, we can see here casting and volume. The given value of V is 0.035 millimeter per second. So we can use mass formula rho into V. So we get some 94.5%, 94.5 kg. So we can secondly calculate shrinkage allowance. So this is example of 500. So we can get 500 mm dimension. Allowance is 0.25 into 500. It's equal to 7.55 mm. So packet length of example is 500 plus 7.5 is 507. So riser volume and total pores volume, so we can get a vr is equal to 20 into v, so we get 0.007, and total pore we can add vp is equal to v plus vr plus we get minus low, so we get vr is equal to 0.007 and vp is 0.0347. So Chernoris rule solidification, uh, so we get Chernobyl road qualification, recommendations and protection, time practice, the friction, and T soap is equal to 0.15 into 947, and getting system for flow rate you can compute that, so we can use formula of Q is equal to Vp minus V4, so we get Q is equal to 18.47 liter per minimum. So we have getting area for orifying equation, so they have some getting area components is 2g, so 2g calculated dimensional appearance, and we can see if the singularity get dimension d is equal to 4, d is equal to under root 4a divided by pi. So component inside is, so we can calculate the d, so d is equal to under root bracket 0.000203 is equal to 14 mm, so we get d is equal to 14.46. So thank you so much, sir.